Hello everyone, I am Genay, a third-year PhD student working at INRIA in France. Today, I shall present our recent TVCG paper, which surveys the work on avatar embodiment in augmented reality. Virtual embodiment is commonly used in virtual reality to improve user integration in virtual environments. However, it can also be used in real environments through AR for many other purposes. Just imagine looking down and seeing another body without having to be immersed. You could experience what it is like to be under someone else's skin in the familiar context that is your own home. Such possibility is only recent, but more and more research is dedicated to improving it, and we thought it might be time to take stock of what we know about it and of what is left to investigate. With this survey, we wanted to provide a guide for newcomers on how to implement virtual embodiment in AR and on how users perceive their virtual body in such settings. More specifically, we're interested in the sense of embodiment, which is the feeling of being inside, possessing, and controlling a body. While there were numerous surveys published on avatars before, none of them are focused on this subject. Because AR enables so many types of embodiment experiences at different levels, we felt there was a need for a taxonomy to describe them more easily. This led us to introduce the body avatarization continuum, which describes the extent of the user's virtual representation within a virtual embodiment system. At the far left is just the user. There is no virtual representation of them. At the far right is what we called full avatarization. This means the user embodies and controls a full-bodied avatar. The regions in between relate to diverse degrees of avatarization, such as partial avatarization, which refers to limb embodiment, such as with virtual hands or legs, and body accessorization consists of lighter appearance modifications, such as changes in hair color or clothes. These terms were used throughout the survey to categorize the analyzed articles. To select the papers of our corpus, we used a small set of rules. First, the paper should describe an AR system as defined by Azuma in 1997. Second, the avatar should be perceptible by the user that embodies it. This means we excluded remote collaboration papers where the user's avatar is only seen by some remote collaborator. Lastly, we decided not to limit our corpus to only full-bodied avatars. We found that it was also important to collect insight from papers implementing embodiment at smaller extents. Once we settled with these rules, we proceeded with an opportunistic approach, which resulted in a total of 33 papers published between 2007 and 2021, with the majority coming from the ACM and IEEE conference venues. So what kind of papers did we find? Most papers were issued from fundamental research on the sense of embodiment, studying the mechanisms of embodiment illusions. Other papers came from application research in fields as varied as medicine, fashion, education, art, or sports. All of them used very different types of implementation approaches, such as by using mobile phones, VR see-through headsets, optical headsets, or camera projector systems. And finally, we could encounter various rendering styles, including point cloud, abstract avatars, or realistic models seen in both first and third-person perspectives. Because this survey is quite long, I would like to focus on a couple of key learnings. First, it becomes clear from our survey that setting up an embodiment system in AR remains a truly complex task, even with today's state-of-the-art technology. Compared to VR, AR embodiment systems have to deal with many difficulties, such as keeping the alignment with the user despite inevitable latency, dealing with real environmental conditions such as bright lighting that can make holograms more transparent, dealing with the usually small field of view of AR devices that can crop the avatarization, making the avatar seem like it's part of the environment with occlusion, collisions, and lighting simulation, and dealing with the fact that the user's real body is visible by default. All of this without mentioning the computing power limitations and the perceptual issues that are usually linked to AR systems. However, AR researchers have shown that there are solutions to many of these problems and that it is nevertheless possible to obtain satisfying embodiment experiences in AR. Using the right technology in the first place can solve a part of these issues. For example, using a video see-through display will allow erasing the user's real body through in-painting techniques, synchronizing video image latency, and making sure the holograms are opaque. But it appears there is no perfect one to rule them all solution, and one usually has to make compromises over many factors. For example, unlike in video see-through, an optical see-through display will provide an unmediated view of the real environment that ensures there is no risk of cyber sickness. If you're interested in implementing avatarization in AR, you can find a complete guide to the different possibilities we could identify in our survey. After surveying the implementation of AR embodiment systems, we also wanted to review existing knowledge on the psychological side. More specifically, we wanted to know if the findings of VR studies on virtual embodiment could also apply to AR settings. But AR is quite different from VR. So our first question was, is embodiment experienced the same way in AR? From the studies we found that compared AR to VR and reality, it does seem to be the case. However, it is still a bit early to generalize these experimental results with confidence, and more research will be required. Next, we wondered if the fact that the real body is usually visible in AR could be in conflict with ownership illusions. Kirchner et al. Showed that real body visibility could indeed weaken the sense of embodiment, but multiple other studies also show that inducing a sense of ownership and agency is still possible even without hiding the real body. Finally, we investigated whether hologram transparency was impactful and found that it can actually be tolerated as long as the virtual content remains more visible than the real content at displays. On the other hand, we did not find answers to many of our other questions, including what is the maximum latency that can be tolerated? What avatar appearances should be favored for a strong sense of embodiment in AR? Or does the Proteus effect also exist in AR? As it seems that implementing an AR embodiment system still requires making extra efforts compared to VR, future research will also need to investigate how to improve current solutions. If you want to know more about avatar embodiment in AR, you will find in our survey further details on application scenarios, measurement methods, simulation strategies, discussions on Proteus effects, and other future directions. Thank you for listening.